25th, that's also about cone. Show that the semi-vertical angle of the cone of the maximum value the maximum volume given slant height is this much. Okay, so I'll just show you cone here. This is a right circular cone, Here I'll take the base height. Base will take R as we did in all questions. Height will take as H. This is a right angle triangle O here. Fine. So here what is given to us? This is L. You are given, let me write first, let R is equal to radius and H equals to height of the cone. We have taken these two as a variables here. And given slant height, okay, and L equals to the slant height given. Slant height given. That means this is treated as a constant. And therefore, if this is L in this right angle triangle, L squared is equal to H squared plus R squared. So this is our equation number 1. AOAB, this is a right angle triangle. Okay, this is a relation between H and R, which we'll use to what you want to do for maximum volume. Okay, so I'll write what we want to do now. So that should be clear in your mind. Okay, you know that this is known as semi-vertical angle, alpha. This is also alpha, half angle. Okay, so we show here, what will show? Alpha equals to how much? Tan inverse root 2. That means you are going to show tan alpha equals to root 2. We show this when this should be shown cone, right circle cone with maximum volume, when volume is maximum. Volume is maximum. So at least you are clear that you want to maximize the volume. Maximize the volume. So you'll get the relation between H and R, and therefore you'll get the L, and then use tan alpha. Okay, tan alpha in right angle triangle, that is opposite upon adjacent. That's the flow of solution, right? So we start with the volume here. Volume, what's the volume here? V, 1 upon 3 pi R square H here. Okay, that you know very well. Now we did it number of times. 1 upon 3 pi R square H. Now obviously we place the value of R square from 1 to convert into a single variable. 1 upon 3 pi. What is R square? R square is here, L square minus H square into this H. This is by 1, by 1. So now this is purely in form of which variable? This is purely in form of which variable? H. Okay, so we take that as the f of H. Pi by 3, 1 upon 3 pi by 3, constant L square H minus H cube. Okay, L is given, that means it's treated as a constant. Now we differentiate it how many times? 2 times. So f dash H, pi by 3 being constant as it is, L square, this is just 1 minus here over here. What about this? This is 3H square. Fine, we'll differentiate it one more time. Pi by 3 being constant as it is, L square being constant, 0. This is minus 6H. So what we are getting from this? This is minus, here you are left with 2 pi H. This is clearly, you can see it would be pi positive, H positive, 2 positive. So this will be clearly negative. But I'll write here, for maximum volume, first order derivative should be 0. From there we'll get the relation that you know now. Okay, so this is non-zero, so we are getting L squared minus 3H squared equals to 0. So we'll get the L squared equals to 3H squared. Fine. And if I put the value of H over here, then obviously it will be negative. F dash H is always negative from the value you can see. Positive, 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 but your minus sign. So For maximum volume of the cone, we have this relation L square is equal to 3h square. But what is L square? L square you can place from the equation number 1. H square plus r square equals to 3h square. Okay, so r square equals to 2h square. Fine, and therefore r equals to root 2h. Fine, this I'll write by 1 here. Now you don't want this h and r. What you want? You want alpha. Okay, so here now you want alpha. So in this triangle you can write tan alpha as opposite upon adjacent. So just look at a diagram and I'll write here from triangle AOB, it is a right angle triangle. Tan alpha equals to opposite upon adjacent. But what is r? That is root 2 into h upon h. So you are getting tan alpha equals to root 2, and therefore alpha equals to tan inverse root 2. That's what you wanted in the beginning. Proved. Why we could derive this? Because of this. You have used that to get the alpha. Why we could find this? Because of the derivative equals to 0. Why derivative is 0? Because you are given that the volume is maximum, and that you notice here also that the double derivative 2 pi h with minus sign is negative, and therefore proved. So question number 26. Show that the semi-vertical angle, so again you want alpha, of right circular cone of given surface area and the maximum volume. Okay, so we have such a right circular cone here. Okay, we take base radius as r and height as h, as we did number of times. Height is h. This is O. Let me call this as A. This is B. Okay. Now let me write here. Let r is equal to radius and h equals to height. That means these are treated as a variable for cone. Okay. Now what is given? That is a constant. What is given here? Given surface area. So you are given surface area. You know how to write the surface area. That is S equals to, how do we write it? Pi r squared base area and plus this this area, that is pi r l. This l is the slant height. So pi r squared plus pi r into, you know how to write this, that is h squared plus r squared. This is our equation number 1 here. This is from right angle triangle. Here L is slant height. This is that slanting surface area. Okay, now what we want to do, let me write that so that picture should be clear in your mind. We show that is what you are asked. We show that the semi-vertical angle, this is known as semi-vertical angle. We show that alpha equals to sine inverse 1 by 3, that is sine alpha is 1 by 3. We show this if what? Volume is maximum. So we take volume as a function, we see that it is maximum, we get the relation between h, r and l, and then we'll use the sine alpha in this right angle triangle. What is sine alpha? Opposite upon hypotenuse. That's what we are going to use here. I'll write here L square equals to h square plus r square. Okay, fine. So we start with volume here. Question number 1 is also very important here. Volume V equals to, it is 1 upon 3 pi r square h. Now the important one is conversion into 1, either in r or h. Okay, now to put the value of r square or h here to convert into single equation by 1, we need to simplify a little bit. Directly it's not obvious. So by 1 you can divide by pi here. S by pi equals to r square. Pi is common. plus r into root of here h square plus r square. Now this is a constant, this is given, that means this is a fixed constant, so I'll take that as a constant c here. Take r square on that side equals to r into root of h square plus r square. What I did here, say that constant s by pi equals to c. You can just call it one constant here. Pi constant, s is given means it's fixed. Now we square it and we'll simplify. S minus here r squared the whole square equals to, you have r squared into h square plus r square. Fine, we're just simplifying. So let's open the bracket here. What we'll get here, c square minus 2cr square plus r raised to 4. Here we'll get r squared h squared plus r raised to 4. So this r raised to 4 will get cancelled. I'll take this one over that side. So c square equals to 2c plus h squared, taking r squared common. Okay, and therefore what is r squared? That is c squared upon 2c plus h squared. Fine. R squared equals to c squared upon h squared plus 2c. That, what is that c? That's a constant. We use this. Okay. Let me call this as, for example, 2. This you can call as main 2. Anyway, that's not important. This is 2. Now we'll put this in our volume of a cone instead of here r squared. So now we'll come to this. So therefore volume of cone, which is v equals to 1 upon 3 pi r square. But what is r square? That is c square upon 2c plus h squared into that h is there. Let this be f of h. Now this is a function of h. Your purely expression about h. Here 1 upon 3 pi c square as it is. You have just h upon 2c plus h squared. This is the expression which involve h. This is the function of h. So we differentiate it now. F dash h. Keep in your mind c is that constant. Which constant? S by pi. Don't forget small c. So 1 upon 3 pi c square being constant as it is. Here you need to use division rule. We differentiate it by division rule. Squared the denominator function. 2c plus h squared the whole square. What about this? Here 2c plus h squared as it is. Differentiation of h with respect to h1 minus here this as it is. 2c being constant 0, derivative of h squared is 2h. So we are getting pi by 3 c squared into, what about this? This is 2c over here, plus h squared minus 2h squared. So just h squared upon 2c plus h squared the whole square. F dash h is this. Okay, and I'll not do f double dash h. This is constant as it is. Differentiate this by division rule. This is for you. Try it. H is involved in this. Keep this one as it is by division rule. I'll leave it for you. Now we'll go to where first order derivative equals to 0 for maximum volume. So for maximum volume of the cone, f dash h must be 0. This much must be 0. This much, that is fh. So this is constant. This will go that side. So you are having just 2c minus h squared equals to 0. This much only. Fine. And therefore you are getting h squared equals to 2 into c. Don't forget that c is that constant. Okay, and therefore h equals to, you will get root 2c. Okay, h is positive being height. You cannot have plus or minus here. And you need to assure that at this place also f double dash h over here must be, you want the maximum value. It should be what? Negative. this should be negative. Okay, now what we'll do, we just come to that equation number 2. So we'll get the relation about that r and h. Okay, so I'll write here by 2. Now we have this relation. If h is root 2c, then first order derivative is 0, second order derivative I have not shown, but I've just written it directly. You must show f double dash h has to be negative, right? And therefore function must have maximum value, that is maximum volume, that is this function volume must be maximum. Okay, now by 2 you have r square equals to c square upon what you have there, 2c plus h squared. What is h squared? That is 2c. So from this we'll get the c square by 4c. So it will be c by 4. Fine up to this. So r square equals to c by 4 here, and h is equal to this or this, whichever you write. Right? So we got this h and r. And now finally when we have this, remember, using the concept that the first order derivative is 0. Now we are interested in sine alpha. So in triangle AOB, just look at a diagram. Sine alpha equals to what we have, opposite upon hypotenuse, that is r by l. Sine alpha is this, opposite upon hypotenuse. Okay, so just place the value here. What is r here? You already shown that r is root c by 2. C is that constant, What is L? Here L is root of h square plus r square. Okay, so here root of, this is L. What is h square? That also just have a look. The derivative equals to 0. So h square will be here 2c. What is r square? That it is c by 4. So we just simplify. Take LCM here. So that 2 will come out and it will get cancelled with this 2. And here you will get root 9c. So it will be just 3 root c. So 1 by 3. This is sine alpha. And therefore alpha equals to sine inverse 1 by root 3. Proved. Why we could prove this? Because we are getting this one and this one. Why we are getting this? Because first order derivative is 0 and second order derivative is negative. Why this happened? Because volume is maximum and therefore proved. Okay, so whenever volume is maximum, then alpha becomes sine inverse 1 by 3. So question number 27, it's an MCQ. There you are given one curve. It's a parabola, x square equals to 2y. Symmetric about y-axis. Okay, which point from this is nearest to 0, 5? This point you are given. Point is here 0, 5. Okay. In MCQs you can do directly from the options. You see which option satisfy this parabola. First thing is this, from options, right? From options you see which option satisfy the equation of the parabola. That's first thing. You find out one option from there, and then suppose there are 2 options or there are all 4 options that satisfy the equation of the parabola. Then find the distance of this from here, distance of the first option from here, distance of this, distance of this, distance of this. Let me call this as, for example, A. If I call this as point P, Q, R, S, get this AP, get this AQ, get this AR and get this AS, and see which one is minimum. That's your required option, right? Nearest to 0, 5 means what? Out of these 4 distances, which one is minimum? This is what the way to handle these MCQs. If you do it subjective point of view, then you need rigorous task. It's like 3 marker. Let that point be unit point on the parabola, right? Let that point be x, y. Okay. Now we get this distance. So therefore I'll write AP square. So what we'll get here? X minus 0 the whole square, x square, y minus 5 the whole square. Okay, now you know this is in two variables, so we need to convert into single. Y square minus, you have here 10y plus 25. How do we convert? This point is on the parabola, so it will satisfy this equation. Yes or no? The point is where? On the parabola, so it will satisfy the equation. So what you need to do, you can just put the value of x squared. So what is x squared? Here 2y plus y squared minus 10y plus 25. Okay, you can see it is purely in variable y. What you have used, point is on the parabola, so it satisfies the equation. So I have placed x squared equals to 2y. Now I'll take this as the f of y. This is square, remember. You must have noticed y of squared here. So it will be free from the square root. So it's easy to handle. Actually this also you can further simplify here. So f of y would be here y squared minus 8y plus 25. Now this is a formation of the function. Now as usual, find f dash y, 2y minus 8. One more time you differentiate it, it is 2. You can notice that it is always positive. Therefore a function must have what? Minimum value. You are asked for nearest. Nearest means distance function should be minimum. So for minimum of f of y, the first order derivative must be 0. So 2y minus 8 must be 0. So y must be 4. Is it? Y must be 4 here. Now also it's quite obvious, but I'm just writing f double dash y is here positive. Therefore function f of y, which is, remember that ap squared, okay, ap squared is here greater than 0, therefore minimum. That is minimum. Now you don't want the distance. It can be asked distance also, but you want that point on the curve. Now you have y equals to 4, so therefore from y squared equals to 4x, using y equals to 4, you will get the 16 equals to 4x. Am I right here? I'm sorry, this is not the parabola. Parabola is x squared equals to 2y. So if I put y equals to 4, you will get x squared equals to 8. And therefore x equals to plus or minus 2. Here x can be negative also, 2 root 2. And therefore here points are 2 root 2, y it is 4. Or the other possibility is minus 2 root 2 comma 4. These are the required points. But here in the options, if you look at, you are not given I suppose negative value. So this is not the required. So this is A is the correct option. Actually no need to do further. When you are doing MCQ, at this place only you will realize there is only one option having y coordinate equals to 4. So you can stop this. The other way I already told you, this is the shortest way to do this from the options. This is I did entire solution just subjective point of view, but in MCQ no need to do this way. You can just do by trial and error from the options, or once you get this immediately you can point out there is only one option where the y coordinate is 4. So you can stop here and directly you can write as first option is the correct option. Okay, 28. Again good question. What is asked? Find the minimum value of this function. This is actually from the range of the function, but here we'll use the concept of the differentiation. So what we'll do, we differentiate this. One time differentiation will do because this is MCQ. So one way is you do division rule explicitly. The another way is you can just write like this: 1 plus x squared. I've added x, so I'll subtract x, so minus 2x. Do individual division here. Okay, so here if I do individual division, this is 1 minus this minus sign, 2x upon 1 plus x squared. Fine. So now of course you cannot avoid the division rule. but little bit it is easier. You could have done directly division rule here. This is 0. I'll not do it, of course. Differentiate this by division rule. Then put f dash x equals to 0. Okay. So just numerator equals to 0. After differentiating once, you need to simplify numerator. Then put this for minimum or maximum value, you know, for turning points. First order derivative is always 0. Right? So from this you will get the values of x. You may have two values. If it is quadratic expression, maximum you will have two values. Now put this values where? In the function directly. Where? In the function. Put these values over here. Okay? If you are getting two values. And from the options, now from the options you can decide the minimum values. Okay? So do it. If you have two, as I told you, two values here, then put both the values and see which one is minimum. That's your required value. You are asked this minimum value, not this. This is called the point where the function has a minimum value, right? Point of minima. This is called point of minima. Minima or maxima, whichever you call it. Minima or maxima. But you are not asked this here. What I'm trying to tell you is, what I'm emphasizing, you are not asked this. You are asked the minimum. What you are asked? Minimum value. Minimum value of the function. Okay? So you need to get to this. You need to get this. That's what I'm emphasizing here. In the 29th MCQ, you have this function. Like the previous question, you want the maximum value. If I just open it, x square minus x plus 1 raised to 1 by 3. This is your function. Fine. Now, as I did in the previous question, you just differentiate it. F dash x equals to 1 by 3 into x square minus x plus 1 raised to 1 by 3 minus 1. That is, you know, minus 2 by 3. 1 by 3 minus 1. So it is minus 2 by 3. By chain rule, differentiation of 2x minus 1. Differentiation of this. Okay. Now, in MCQs, normally you have options, so no need to go for double derivatives here to decide maximum or minimum value. So what we'll do now, for, you know, maximum value, we put f dash x equals to 0. So put f dash x equals to 0 here. Okay. So this being, you know, negative power, it will go down. This will be in the denominator. So just we have 2x minus 1 upon 3 into x square minus x plus 1 raised to 2 by 3 denominator equals to 0. So x is just half. X is how much? Half. And it is between 0 and 1. Keep in your mind. Okay. Now what we'll do, we just put this one in the function. Because what is asked here, you are asked for maximum value. So this is a turning point, you know, right? This is turning point. Turning point. And function is defined, you close interval 0 to 1. Keep in your mind. So we find f of half. Put this half in the function. We find f of 0 and we find f of 1. Because here function is defined on the closed interval. Right? Okay. What is f of half? I'll just put into the function. So you will get half here, then into, you know, half minus 1, that is minus 1 by 2 plus 1 raised to 1 by 3. So this is minus 1 by 4 plus 1, which will be 3 by 4 raised to 1 by 3, value of the function. Okay. Then we'll put 0. If I put 0 here, this is just 1 raised to 1 by 3, which is 1. Okay. And finally, what you are going to put? 1 here. 0 and 1. Domain is closed interval. Such questions you had earlier. So if I put 1 there, 1. This is 0. Again plus 1. So you have 1 raised to 1 by 3, which is 1. So which one is maximum? This is less than 1. 3 by 4. So either you can use this or this. So the maximum value equals to what? 1. It attains at both the endpoints, at 0 as well as 1. And that's correct. Option is here, I suppose C. The correct option is C here.